Hello, today we are going to learn how to make a library and a file inverter in the library. Open Electric and click on File. Then click on New Library. Name the library as you want it. Let us start by making a new cell in the library. Click on Cell and New Cell. First we'll start by making a schematic for inverter. Let us select schematic and name it as inverter. Now in the record library a schematic called inverter has been created. This is called as our workspace. Let us start here in the Explorer. Here we have an Explorer tab and the Components tab. In the Explorer tab we can see the cells and files that we have created. In the Components tab we can see different components. This is a PMOS whereas this is an NMOS. You can read the description of the components at the bottom of the screen. Let us start by placing a PMOS on the screen. Now let us place an NMOS below it. Let us place a VDD source and ground on our screen. Now that we have placed the components for an inverter, let us start by connecting them. Left click on the component to be connected and right click on the other component. This is how a connection is made. This connection is called a wire. Now let us connect the two gates of the PMOS and NMOS. This is our inverter schematic ready. Now we need to connect nodes which will give input and take output from the inverter. We place the node on the screen. Now connect the nodes to the input and one to the output. We need to size the transistors because the minimum specification for width is 10 and length is 2. Double click on the transistor to select it. Now we need to export the nodes so that the software knows which is the input and which is the output. Select the node, go to Tools, go to Export and say Create Export. You can name it as in for input. Similarly, we can name this node as out. Another way to create an export is to press Ctrl E. Let us name it as out. VDD and ground don't need to be exported separately. They are done so by the software. Now we need to define that this is a PMOS and this is an NMOS. So select the object that we need to define. Then go to Tools, Simulation Spice and Set Spice Model. We can see here that the spice model has been set. Now select the spice model and press Ctrl I to open the properties. Name it as PMOS, keeping all the letters capital. Similarly, set spice model for the NMOS. Tools, Simulation Spice and Set Spice Model. You can also double click the name and rename it as NMOS. Now the schematic for our inverter is ready. What we need to do next is write the spice code to run the schematic. Select miscellaneous and then spice code. Place the spice code anywhere on the workspace. You can see that the spice code has been placed. Now select it and open properties. We can do so by clicking Ctrl I. This is the spice code window. We need to select multi-line text so that we can write multiple lines in the spice code. Now let us write the spice code in the window. Let us start by defining VDD. We are saying that VDD is a source which has the value 5 volts. Let us define our input signal. We will name it as Vin. Then we write the name where we want to give the input, that is the name of the export. Then we write PWL, that is piecewise linear. Then we define the shape of the signal. At 10 nanoseconds the voltage is 0. At 20 it is 5. It stays 5 till 50 nanoseconds. Then it falls down to 0 at 60 nanoseconds. We need to give C load, that is a load at the output, to simulate we need to give C load, that is a load at the output, to simulate the load that the circuit might carry in future use. We give the load as 250 femtofarad. We will perform transient analysis on this circuit. So let us write tran. The analysis is performed from 0 to 70 nanoseconds. Then we need to include the C5 model file. So we define the path where the C5 model file is. Make sure that the path is given correctly, or the program won't find the file in place. Now we have written our spice code. Click on OK to save it. We can see here that the spice code has been included in our workspace. We need to check if our schematic is working properly. So let us simulate this design. Click on Tools. Then go to Simulation Spice and click on Write Spice Tech. The LT Spice window will open. Then click on Pick Visible Traces so we can add the input and output which we want to see. Then click on OK. As we can see, when the input starts rising, the output falls. When the input is high, the output is low. And when the input starts falling, the output starts rising. And when the input is low, the output is high. Hence, we have simulated the inverter successfully. This is how we make a schematic of an inverter.